as we in Hamburg say, moin. This is a greeting, so moin to the whole audience. I would like to talk in this presentation about how to use meaningful names to improve API documentation. To start in the talk, I would like to get more in detail what I mean about improving and API documentation. So what does improving mean? As you all know, writing API documentation is a very hard task, and there are several obstacles we need to shift around when writing it. And I think Martin Robillard has summarized in his great article what makes APIs hard to learn, some of them which we should take care about. The first recommendation of Martin is to use good examples in the API to show how it works, how it should be used. The second one is to be complete, as Michael said in his last presentation. The next one is to include many complex usage scenarios and not only the simple cases. Then to organize it conveniently, and last but not least, include relevant design issues and design reasons. So I think all of them are very important, but I have not the time to talk about them in all, and so I would like to focus on one of them to be complete. So when I talk about improving API documentation, my goal is to make it more complete. I have to be a bit more precise about the term API documentation. I do not speak about API documentation in general. I just focus on API references. So let's take an example. I took this one. I think it's pretty good to see what I want to transport. It's taken from the Java Mail API, Java 8 Mail API. We have a public abstract class transport, and it provides a method which is called send, and it has one parameter which is called MSG, a message, and it can throw an exception. So I think API documentation often contains gaps, and I'm a developer. I use tools to derive what to write in the API documentation. And I think Java Doc, for example, is a good representative candidate to see how the tools support right now and what could be improved in the support. So when I'm in IDE and I try to write my code and I want to get support in writing the documentation, I start with /**, and then I press return, and the Java Doc support generates some kind of pattern for me. And I need to fill it as a developer. And in most cases, I saw that someone wrote param MSG, for example, the message, and then messaging exception in case of any error. And at the beginning, there should be a summary of what the operation does, and I often saw something like this, sends a message, and that's it. Is anybody here who haven't seen this also? So this is a often convenient style from my point of view in API documentation. And the question is, could it be improved or could it be better? And is there any way to provide a tool which supports the improvements? So, well, I think one can think about, so the idea is what would be better to be mentioned. And my idea is, well, if you look at this, you have no information about how the message, the addressee of the message is specified. So there is no parameter addressee, for example. And this operation signature does also say nothing about the infrastructure which is used to transport the message. It's also not covered in the operation signature for good reasons. The second one, when you send an email, you could send it as plain text or as HTML, so there are different formats. And you here, there's no possibility right now on the signature to specify the message format. And I think that's the same with exceptional states. So you have one exception, but you can imagine of several errors which occur. For example, email address is invalid or mailbox is full, something like this. And here, only one message exception is derived, and you have to describe it on your own. And the question was, is it possible to build a tool which provides more deep recommendations about what to document in the API documentation? From my point of view, all tools I know, like Swagger, JavaDoc, and all the others, are focusing on the signature. So they focus on the parameters, the exception, maybe the result, and that's it. So is there an approach to make it better? And I guess yes, and my suggestion is to use the name of the operation to derive interesting or relevant aspects. So you might now ask why the name? And I would like to give you an example. We are in the Auto Club, and I personally have a passion for Volkswagen buses. And so I would like to take the Volkswagen bus as an example. How many of you know what a Volkswagen bus is? Okay, I've expected that. But to complete the example, I would like to present a specification. You can see here an abstract specification of what a Volkswagen bus is. To be more precise, it's a Volkswagen Type 2 T3. It's built in the 80s, and you can see it has a width of about, or a length of about 4.5 meters. It has a rather box design. You can see below there are 8 seats inside, so 8 people can get in the cabin. The cabin is quite huge. And well, I say to you, this is a Volkswagen Type 2 T3. And the name of this object is Volkswagen Type 2 T3. And with this knowledge and background, you are able to verify when I put an object on the table whether this is a Volkswagen Type 2 T3 or not. So for example, I put this one here, and you might have a look on it and say, well, okay, it has also a cabin, only 1 seat, oh no, 2. There is also one in the back, okay, 2 seats, but not 8, 4 wheels, but different size. So I guess most of you would say, though, this is not a Volkswagen Type 2 T3. And I said, yeah, well, okay, I'm convinced. What about this? This is my bus, to be honest. You might see there's a small difference between the specification and this photo, because there is the roof. You can move the roof up so to get more space in the cabin, but in general it fits the sizes and the structure of this specification. And I guess most of you would say, okay, this object B is a Volkswagen Type 2 T3. So my suggestion is to transport this principle to the API documentation. And I suggest a 3-step process. The first step when you want to document an operation is to find a meaningful verb which describes what the operation does. The second one is, I imagine you have a lexicon. You can look up with the verb in the lexicon a matching abstract specification. And then finally, you can match the specification against the actual API documentation. And I would like to do this on the example I gave before. So you might think about several verbs. I have collected some examples here. We had the verb to send, but it's also possible to say submit or notify. Maybe there are some others. But important is that you have a verb, and all these verbs have a very similar meaning. And my idea is to look up in a dictionary and to find such abstract specifications which collects recommendations on the API documentation. So for example, if you have a submitting operation, you can nearly ask in every case, what is the destination of the object which is transmitted? And you ask, well, what's the object which is transmitted? And which infrastructure is used to transmit the object? So there are several things which might be asked in general, and as the author you can go through this pattern and say, okay, well, I would like to mention this, I do not want to mention this, I think this is important and this not. So, but you have a grid where you can follow. And I did this for the actual API documentation of the Java Mail API. I took you do not need to read all this text. I guide you through. I took the original API documentation, I cut it into pieces, and I assigned each piece to one of these abstract patterns in my collection. For example, I choose here this Java doc notation. I set at destination, and there is something about the addressees. For example, here, in this case, you can specify the addressees via an addressee method on this message object, and they are collected, and then the message is transmitted to all of them. Or for another example here, the instrument, the author says that there is a new connection for each message which is sent. It's a static method, and so there is no reuse of existing connections. So what I've shown here is how to use this to derive, for example, resources or other aspects for the documentation, but you can also use this concept to derive exceptional states, because it is in general possible to ask, well, what does the operation do if the, for example, destination is not available? And you might now derive certain error cases. For example, the email address is invalid, or the box limit is exceeded, or what else. It doesn't matter, but the idea is that you think about the errors very focused. Yeah? You do not have to think of all errors which can occur, but you think only, well, what does it mean to my operation if the destination is missing? Or, for example, if the instrument is missing. This is the basic idea. So you cannot derive concrete exceptional states with this approach, but you can derive categories and think about within the category more detailed. And I did this also here for the destination and the instrument. So most of my research was about building this lexicon, I said. And I found several types of operations. I collected them here in the shelf. For example, submitting operation, which we have seen, or connecting operations. There are checking operations or establishing operations, so a lot of operations. And I've described them all by a pattern, as I showed you. And I put this pattern here on GitHub, on my GitHub account, so you can have a look at them. And I would like to show it for very short. Here. So this is the main page of my GitHub account, and you can click on Browse the API documentation pattern, and here there is this list. For example, we can have a look in the pattern definition of this submitting operation, which was of the example. Here I have a very abstract text where the different kinds of arguments of these operations are explained and put into relation to each other. And here's a suggestion of verbs you can use to express that this operation has this responsibility, submitting messages, for example. And here there's a list of all these abstract arguments you can think about to document. So, and now, for example, if you are not sure which kind of pattern could be applied, you can use the GitHub search function, for example, to search for the verb to add to get the matching patterns. And then you will see, for example, this could be a computing operation, or you could put something somewhere, a depositing operation, or you merge two objects by adding it. So it could be a merging operation and so on. This is the only available application of this approach. So right now I have no tool. I'm very sad, but I didn't find the time to develop one, to add it to Javalog or something like this. But yeah, they are available at GitHub, and you can have a look on them if you want to. Yeah, and basically that's it. Short summary of the advantages of my approach. You are able with this approach to identify characteristics of an operation which are not obvious at the signature level. And you do not need additional sources to this. So there is no need for source code which has been should be analyzed. The name is just enough. You are also able to derive exceptional states, so causes of errors. And last but not least, I think using more precise verbs also increases the readability of the API. When I considered this lexicon, I had took an analysis of about 180,000 web service operations. And are there any suggestions which might be the most frequently used verb? It was to get. Yeah, over 80,000 times to get. And to get is the meaningless verb. You can say, well, nearly in every situation where you receive something. Yeah, and that's all. Thank you very much for your attention.